Guys, in week one, we introduced organic compounds. You learned how to differentiate between alkanes and alkenes, and you learned a whole bunch of functional groups, the aldehydes and the ketones and the alcohols and the ethers, and the carboxylic acids and the esters and the amines and the amides. So that's amazing. That's fantastic. All right, so now what we're going to do is we're going to take all those different functional groups and we're going to talk about all the chemical reactions that you're going to need to know and be able to identify because you're going to be using them in the biochemistry. All right, so the topic of this week is reactions of organic compounds, okay, or organic reactions, something like that. All right. So if you look at the what you need to know list, you will see 7 different reactions. Now, there are tons of reactions in biochemistry, and I just chose 7 categories to focus on those. And you will be seeing them, like I told you, throughout the semester. So right now, let's get started with the first one. And the first one is hydrogenation. Hydrogenation. And you may have heard that term before. Have you heard of hydrogenated vegetable oil or hydrogenated fat? So the term hydrogenate just means adding hydrogens to something. And on a molecular level, all that is think of an alkene that has double bonds, and you're adding hydrogens. Remember how when we were creating alkenes, we removed 2 hydrogens? So what you're doing in hydrogenation is you're adding hydrogens to the double bond. So if you see a molecule or if you see this type of a reaction, like you've got something like this, for example. I did it this way because there's something in double bonds called cis and trans. We're going to get into that when we do the lipids, because you may have heard of the term trans fats, and trans fats aren't the good ones, cis are better. So this over here is like a cis. But anyway, don't worry about that right now. This is a double bond. You don't even have to do this. You can have it like this too, all right? Either way is fine. So you have an alkene, something that has a double bond, and what you're going to do is you're going to add a molecule of hydrogen, all right? A molecule of hydrogen. If you remember from intro chem days, hydrogen is one of those diatomic molecules, so it always, when it's by itself, it's always H2. 2 hydrogens are together. You never see one H by itself. It's always 2 hydrogens together, okay? You know, oxygen is diatomic, fluorine, chlorine, iodine. I don't know if you remember the 7 diatomic molecules. Anyway, hydrogen, whenever we're talking about a molecule of hydrogen, it's always H2. So what's going to happen? The double bond is going to break, okay? And then you will see, all right, let's see this. And now the 2 hydrogens have hooked up here and made it into a saturated alkane. You know what might be easier is if I actually expand it out. I think you'll be able to see it better. So let's say I have something like this. All right, yeah, this will be better for you guys. So here, this molecule, I have, this carbon's got 3 hydrogens, this carbon's got 3 hydrogens. This carbon only has 1 hydrogen because of this double bond. Here's 1, 2, 3, 4 bonds. 1, 2, 3, 4 bonds. Okay, so when you add a molecule of hydrogen, let me erase these line drawings. This is easier for you guys to see. If you have a platinum catalyst, sometimes they'll use platinum or they'll use a nickel catalyst, and you have pressure and heat. Like, this is not something you can do in the lab, you know. So you need pressure, heat, platinum catalyst. This bond will break, okay? The double bond will break. And then what will you see? All right, and then you're going to see these two hydrogens, this guy over here, this is an H and an H. One H will come here and one H will come here. That's what a hydrogenation reaction is, all right? And when do we see this in biochemistry? When we are hydrogenating unsaturated fats and turning them into saturated fats. And you'll see this in the lipid chapter. You can take a nice oil that's filled with unsaturated fatty acids and then add hydrogens and turn all the unsaturated fats into solid saturated fats. The food industry uses that. This is how they make margarine. This is how they make Crisco, you know, that solid white Crisco. This is how they turn liquids into solids, liquid fats into solid fats by hydrogenating. And what does hydrogenating do? It turns the double bonds into single bonds. So it's like turning an alkene into an alkane. All right, so that's the first reaction. I need you guys to be able to recognize that and tell me, oh yeah, that reaction is a hydrogenation. And if I ask you, how does a hydrogenation work? What happens? Means you have to add a molecule of hydrogen. Now, if a molecule's got 2 double bonds or 3 double bonds, then you need to add that many molecules of hydrogen. So let's say you have a molecule that has 3 double bonds, you need 3 molecules of hydrogen. So basically something that has double bond here, double bond here, double bond here, you're going to have to add 3 molecules of hydrogen, because remember, and one H will come here, one H will come here, one H here, one H here, one H here, one H here. All right, so depending on how many double bonds the molecule has, that's how many hydrogens you're going to have to add, hydrogen molecules you add. All right, so the next one on the list is hydration. Okay, hydration. Okay, when I tell you, are you hydrated? Did you hydrate? What does that mean? Water usually means the term water. Did you drink enough water? Is there enough water? So when you hydrate in a reaction, that means you are adding water. Hydrogenate means you're adding hydrogen molecules. Hydrate means this is the addition of water. Now, you know water as H2O, but in chemistry, we like to think of water as HOH, okay? Think of it as an H and an OH, a hydroxide and a hydrogen. And the reason we do that is that when water is added to a molecule, one H goes one place and the OH goes in the other place. When does this happen? Well, I don't know if you've had a biology class, you may have heard of the Krebs cycle. In the Krebs cycle, which is so important for carbohydrate metabolism, lipid metabolism, protein metabolism, very, very important cycle in your body. There's a reaction with a molecule called fumarate and it becomes malate. Don't worry about that now. We'll get to that later on in biochemistry. But this is a hydration reaction where you have a double bond. So you have something that looks like this. I'll expand it so that you can see it really well. Doesn't matter what the rest of the molecule is, but you have an alkene, something with a double bond, and then you're adding HOH, okay? And this reaction will only work if there's some type of catalyst, okay? So the catalyst is usually an enzyme. Remember, a catalyst is something that will speed up a reaction. So if you were doing it in the lab, you would need an acid catalyst, but in your body, it's a specific enzyme that will help this one go forward. And what happens? The double bond breaks, okay? Double bond breaks. And again, it won't happen without an enzyme. It won't happen without a catalyst. So like I said, in lab, it can work with an acid catalyst, but in your body, let's see, can you guys see okay? Yep. You need the enzyme fumarase for this to work. All right, what happens? The H comes here, the OH comes here. So if you see a reaction where I am adding water to a double bond, you know that this is a hydration reaction. If you see a reaction where I'm adding hydrogen molecules to double bonds, that's called hydrogenation. Okay? Great. All right, in the next video, we'll do oxidation and reduction and maybe get to esterification also. Okay.